Hey 6th graders, this is lesson 9-3 and today we are learning about comparing positive and negative numbers, which one is greater, which one is less, as well as a term called absolute value that we'll learn later in the lesson. So let's go ahead and get started. So we're going to be using this number line to help us understand the first section today. It says this number line has two directions, left and right. So just to be clear, left is going to the left and right is going, of course, to the right, just to make sure we understand what those directions are. Okay, then it says number one, as you move to the right on the number line, do the numbers increase or decrease? So if you were moving to the right, the numbers get bigger, they increase. As you move to the left on the number line, do the numbers increase or decrease? As you go left, if you start at 8 and you go down, they are decreasing. They are getting smaller and smaller. And one thing that kids get a little confused about is we say, well, what if we start in the negatives? If you go back to number 1 and you move to the right, do the numbers increase or decrease? Well, some kids go, wait, if I start at -8 and I move to the right, it looks like the numbers are decreasing because they're going 8, 7, 6, 5, they're going lower and lower, but that's actually not true. On a number line, it doesn't matter if it's positive or negative. The rule is if you are going towards the right, it's always increasing. So actually, if you start at -8, any numbers to the right of that are actually greater. So for example, -7 is greater than -8, which might seem a little bit weird because you're like, wait, I thought 7 is smaller than 8. Yeah, but when you're talking about negative, it's your distance from 0. So anything to the right is increasing, anything to the left is decreasing, okay? Now, number 3. If two numbers are placed on a number line, is the number further to the right the greater number or the lesser number? So they're saying if you have any two numbers, like let me just use two different pens here, okay? If you have any two numbers, I'm going to put one on -4 and one on +1. Okay, that's where my two pens are. The question says, oh, I can't read it. Is the number further to the right the greater number or the lesser number? So the one to the right, is it bigger or is it smaller? We have 1 versus -4. Some might say -4 because you think 4 is bigger than 1. But the rule is whatever is further to the right is the winner. So in this case, 1 is bigger than -4. So the one that's farther to the right is the greater number, always. Okay, if it's farther to the right, it is greater every single time. Okay, if two numbers are placed on a number line, and the number is a number that's farther to the left, the greater number or the lesser number. So we'll do those same two numbers again, 1 versus -4. It says the number on the left, is that greater or is it less? Some kids would say greater because 4 is bigger than 1, but this isn't 4, it's -4, okay? And it's to the left of number 1. So if it's further to the left, it's actually a smaller number, it is less. So it's the lesser number. So if it's further to the right, it's the greater number. If it's further to the left, it is the lesser number. Okay, and I know that is a little bit trippy for your mind to think about because we are so used to thinking of just positive numbers and our brains are so used to thinking of, oh, if the numbers are bigger, they're bigger, but it's not always like that. On the number line, you have to think of what's further to the right, which gets opposite. That's why we call them opposite integers when you're talking about positives and negatives. So you have to think. All right, so now we're going to be comparing. Some of you would be able to whiz through this very quickly on your own. Some of you would, if we were in class, would really need to be looking at this number line. So I'm going to use the number line, just assuming that there might be some of you watching this video that would need that support. So -1 versus -4. Your instinct might be to say -4 because 4 is bigger than 1. But when you compare -1 versus -4, which one is further to the right? The one that's further to the right is the bigger one, which is -1. So -1 is the winner. And if you remember in alligator symbols, he always is hungry and has his mouth open to eat the bigger one. So -1 is greater than -4. 2 versus -2. Okay, here they are. Which one's further to the right? 2. So I'm going to eat the 2. 4 versus 5. They're both positive. So 5 is further to the right. 5 is the winner, which we should have known already because we already know how to handle it when they're both positive. -5 versus 5. Okay, which one's further to the right? This one. Some kids think -5 versus 5 are equal because they both have the number 5, but the one that's further to the right is the +5, so that is the one who the alligator eats. It's bigger. Number 9, 0 versus -7. Which one is further to the right? The 0, that's the bigger one, so the alligator's going to eat that. -3 versus -2. A lot of kids will say -3 because if we were doing positives, 3 is bigger than 2. But when you're doing negatives, you have to think of which is further to the right. -2 is further to the right, so that's the bigger number. Number 11, -2 versus -6. Here we go, -2 versus -6. -2 is further to the right, so I'm going to eat that. -4 versus 0. Which one is further to the right? The 0. -3 versus 1, versus a +1, I should say. The 1 is further to the right. -8 versus -8. Oh, that's the exact same thing. They're sharing a point. If my pens are the same one, they're actually equal. 9 versus 7. Those are both positive. I know how to handle those. 9 is bigger. But if you wanted to check on the number line, 9 versus 7, 9 is the bigger number. And -1 versus -7. So we have -1 is further to the right, so that's the bigger one. Okay? So when you're comparing, you can always think of what is further to the right. That'll always be your bigger number or your greater number. The next section says write the numbers in order from least to greatest. We're going to have to be careful because the next section says greatest to least. So we want to make sure we're doing this in the right order. So from least to greatest, we have -2, 0, and -1. So -2, 0, and -1. Okay, so it's where I put those 3 dots. From the least is going to be the left, so I'm going to put -2 first. And then we're getting bigger, which should be -1. And then our biggest one is 0. Now that seems so weird. Usually we're thinking of 0 as the smallest number, but in this case, if you have some negative numbers, 0 is actually greater than the negative numbers. Number 18, we have 6, and we have -3, and then we have 7. So from least to greatest, -3 is the furthest to the left, so it comes first. Then we have 6, and then we have 7. So we're going from left to right, least to greatest. I can even write that down. Left to right. Okay, number 19, -9, -1, and -6. So -9, -1, and -6 is right here. Okay, so least to greatest, which one comes first? The -9 is on the left. Then comes -6, and then comes -1. All right, I hope this is helping you guys to think of it as on the left is smaller, on the right is greater. Okay, so now we're going to do opposite, greatest to least. Okay, so first we have -3, 0. So -3, 0, 5, and -1. Okay, so with those 4 numbers, we're doing the greatest one first. So we're starting from the right and then going to the left because it's greatest to least. So the greatest one is 5, and then 0, and then -1, and then -3. Number 21, says -10, -7, -5, and then a +6. So these ones I'm looking at are the blue ones. So from greatest to least, we're starting furthest to the right, which is all the way over here, which was 6. And then we had -5, -7, and -10. Okay, now in our last section, it says we have -1 and -9, 0 and -2. Okay, so greatest to least is furthest to the right, which is 0, which makes sense to me because none of these are positive numbers. So 0 is the biggest one. And then if we're going smaller and smaller, we go backwards to -1, then -2, and then down to -9. So I used the number line for these. Our directions said that was okay. It said use the number line below for exercises 1 through 22, which was all of what we just did. I would hope that with practice, you would be able to solve problems like this in your head just by thinking about it without using the number line as a visual aid. So if I gave you 3 numbers, like on number 18, 6, -3, and 7, the goal would be for you to be able to order those least to greatest or greatest to least without looking at a number line. It would be better for you to visualize that number line in your head so that you can do that mentally instead of having to have the visual. All right. Our next page says our new topic, which is absolute value. So the symbol right here in these 2 lines is used to indicate something called absolute value. Absolute value is a measure of the distance a number is from 0 on a number line. So this number line shows that 4 is a distance of 4 unit lengths from 0, right? So here's the number 4. It is 4 away from 0. Now, because 4 is 4 unit lengths from 0, the absolute value of 4 is 4. We record the fact by writing this. I'm just going to write that again. So if you want to know, hey, what is the absolute value of 4? That means how many distance or how many unit lengths is it from 0? Well, how far away is 4 from 0? It's 4 away from 0. So that's how we write that. Now, since absolute value is a measure of distance, and the distance between 2 points can never be a negative number, absolute value is never a negative number. Okay, so the answer to an absolute value question can never be negative. Because if you ask somebody how far something is, what the distance is, it's not possible to have a negative distance. It just doesn't exist. So this number line shows -3 is 3 units from 0. Okay, so when you say, hey, what is the absolute value of -3? You put -3 in those 2 lines, and you're asking yourself, hey, how far away is -3 from 0? When you ask yourself absolute value, that's what you're asking, is how far away is it from 0? It's the distance a number is from 0. How far away is it from 0? Well, how far away is -3 from 0? Well, we don't say it's -3 away from 0. We just say it's 3 units away from 0. So the absolute value does not tell you the direction. It does not tell you if it's positive or if it's negative. It just tells you how far away is that number from 0. So 4, it was 4 away from 0. -3, it was 3 away from 0. So the answer to an absolute value will never be negative. All right, so it says that right here. Absolute value is a measure of the distance a number is from 0 on a number line. So the absolute value of 0 is 0. How far away is 0 from 0? The absolute value of 0. How far is 0 from 0? It's not far away from itself at all. It is itself. So we just say it's 0 distance away from 0. Okay, so we're going to find the absolute values of these. Absolute value of 5. How far away is 5 from 0? 5. Absolute value of -1. How far away is -1 from 0? It's 1 unit away. Absolute value of 2. How far away is 2 from 0? It's 2 units away from 0. Absolute value of -4. How far away is -4 from 0? It's 4 units away. Absolute value of -2. How far away is -2 from 0? It's 2 units away. Absolute value of 3. How far away is 3 from 0? 3 units away. Absolute value of 0, so one we did right here. How far away from 0 is 0? It's 0 units away from itself. Number 30 is absolute value of -5. How far away is -5 from 0? It's 5 units away. So I want you guys to notice that on all of these, the answer to the absolute value is always positive, and it's always just the number that you started with, except you can't have a negative one. So the absolute value of 5 is 5, absolute value of -1 is 1, absolute value of 2 is 2, -4 is 4, -2 is 2. You guys kind of get the idea. Absolute value is a very, very simple concept. It's just asking how far away is it from 0. So the number's always the same, it just can't be negative. Okay, we're going to rewrite each sentence using only integers and symbols. So we're not going to use any words. Okay, we can do this. The absolute value of +10 equals 10. So they're saying the absolute value, so we have those two tall lines, of +10, so we don't have to write the positive sign, we can just put 10, equals 10. All right? The absolute value, make our two long lines, of -18, so -18 equals 18. All right, the absolute value of 25, so here's our absolute value symbols, absolute value of 25 equals 25. The absolute value, so here's our lines, of -30 is 30. All right, so hopefully you guys are getting the idea there. Our next page is absolute value and opposites. So we're going to use this number line to help us with the next couple of questions. First it says, plot a point at 8 and plot a point at -8. All right, here's a point at 8, here's a point at -8. What is the absolute value of each number? Okay, well, how far away is 8 from 0? It's 8 away from 0. How far away is -8 from 0? It's 8 away from 0. So, are 8 and -8 opposite integers? Explain why or why not. Yes, they are. We can say both integers are the same distance from 0. And that's pretty much the definition of what opposite integers are. It's just the same number, one's positive and one's negative. But another way of saying that is they're the same distance from 0. And yes, that makes them opposite integers. So now, write a generalization about the absolute values of opposite integers. Okay, so what can we say about when you have opposite integers? What do we know about their absolute value? We can always say they have the same absolute value, because if you think of any opposite integers like -7 and 7, -5 and 5, -1 and 1, -100 and 100, their absolute values are always going to be the same, just like they are here, because the absolute value is just asking how far away is it from 0. So that's what we can say for our generalization. We can say opposite integers have the same absolute value. That will always be true. If they are opposite integers, then they will have the same absolute value every single time. All right, so then it says use the absolute value to compare the numbers, and then use the symbols. Okay, so we could do what we did on the first page and think about further to the left means it's less, and further to the right means it's more. But they're having us think about the absolute value instead, just a different strategy. Whatever works better for your brain in the future is what you can do in the future. So the absolute value of -5 means it is 5 away from 0, but it's negative, so I'm going to say it's left 5. And the absolute value of -4 is 4. It's 4 away from 0, but it's left because it's negative. So if we're going to compare these, if you're left 5 or left 4, well, which one is bigger? Well, the one that's further to the left is always smaller. So this one is bigger. All right, so on our next one, the absolute value of -1 is 1, but it's negative, so we are going to the left. Absolute value of -3 is 3 because you are 3 away from 0, but we are remembering that we are moving left because it's negative. So if you are left 1 or left 3, which one is going to be bigger? Or which one is going to be smaller? Well, if you're further to the left, that's a smaller number. So left 3 is going to be smaller than the other one. So I'm going to say is -1 is our larger number or our greater number because it's further to the right and this one is further to the left. Number 40, -2 versus -5. Well, -2, the absolute value is 2. It's 2 away from 0. And -5, the absolute value is 5. It's 5 away from 0. But they are both to the left of 0 since they're negative. So which one is going to be bigger? Well, if you're left 2 or left 5 means you're really far left, which means you're smaller, so the other one is bigger. So we will use this symbol and eat the -2. It's bigger. -6 versus -6, I can see just by looking at those are equal. If you wanted again to prove they're equal, the absolute value of -6 is 6 because it's 6 away from 0. It's the same thing both times. And they are both negative, so they are both moving to the left. So we have left 6 versus left 6. Those are equal to each other. All right, so you can think about absolute values to compare. Personally, I prefer this method of just visualizing it on the number line. I think it's easier, but if you want to do absolute value, you can. All right, Puzzle Penguin says, Dear math students, I was asked to use absolute value to compare 2 positive integers and 2 negative integers. The positive integers were 10 and 5, and the negative integers were -10 and -5. Okay, so he's comparing 10 versus 5, and he's comparing -10 versus -5. I know that 10 is the absolute value of both 10 and -10, and I know that 5 is the absolute value of both 5 and -5. So far, is that true? Let's check this part right here. Is it true? Is 10 the absolute value of 10 and -10? Is 10 away from 0? And is -10 10 away from 0? Yes, this part is true. And is 5 the absolute value of 5 and -5? Is 5 away from 0? And is -5 5 away from 0? Yes, this is also true. So yes, this is true. I decided that the greater absolute value is the greater number. So I wrote 10 is greater than 5 and -10 is greater than -5. Can you explain to me what I did wrong? Because of course he always does something wrong. Your friend, Puzzle Penguin. So what is it that he did wrong? He said that 10 is greater than 5 and -10 is greater than -5. And he decided that because they all have the opposite integers have the same absolute values. So what I would tell Puzzle Penguin is that if you use absolute value, to compare the negative number with the greater absolute value is smaller. So basically what he should have done is not this. This first one was good, but he should have said this. Because if you're using absolute value and you're talking about negative numbers, with both numbers being negative, the bigger negative number is actually smaller than the other negative number. So he got confused. Personally, I think maybe you guys might get confused. I think using absolute value to compare is not the best idea. That's just my opinion. Maybe it works for you. I think the easiest way to think about it is what we did on this first page, and just think about a number line and visualize it. If it's further left, it's smaller. If it's further right, it's bigger. Then, in my opinion, you probably won't get messed up. All right, our last page for this lesson says, solve. Use the situation below for the next two problems. Okay. It says a thermometer shows a temperature of negative 10 degrees Fahrenheit. A nearby thermometer shows a temperature of negative 12 degrees Fahrenheit. Explain how a number line can be used to find the warmer temperature, and then name the warmer temperature. Okay, so if you wanted to use a thermometer, we could go like this. And I'm not going to put all the numbers on here. I'm just thinking that these are both negative, so they're already going to be below 0. So we'll say if this is 0, I'm going to skip by 2 because these are even numbers. So negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. And explain how a number line can be used to find the warmer temperature. So we have negative 10 and negative 12. Which one is warmer? The warmer temperature is negative 10 degrees Fahrenheit because it's above negative 12 degrees Fahrenheit on the thermometer. Right? And usually a thermometer is a vertical one. That's why I chose this. And on a vertical one, we learned on our first page that, actually, it was in our last lesson. We learned that on a vertical one, as you go up, they get bigger. As you go down, they get smaller, right? So if we have on our line, we have negative 10 versus negative 12. Negative 10 is warmer because it is bigger. All right. So then we can say for the next one, explain how absolute value can be used to find the cooler temperature. Okay, so if we wanted to use the absolute value, we can say they are both negative, right? So they're both below 0. Thinking of absolute value of negative 10 is going to be 10. It's 10 away from 0. And then absolute value of negative 12 is 12. It's 12 away from 0. So they're both negative. So if we want to find the cooler temperature, is negative 12, this one, because it has the greatest absolute value. And they're both below 0. So if you have one that's above 0 and one that's below 0, you can't use that strategy. That's why I don't love the absolute value strategy, because it kind of depends on if you have positives and negatives, or both positives or both negatives. It kind of just depends. It's more things to memorize. So they want to know, how can you use absolute value? Well, we can. I don't love it personally. I think the strategy above makes more sense when you're just thinking about the thermometer and which one is higher and which one's lower, which one is cooler. The one that's below further, because the further down below you get, the colder it is. But if they did ask about absolute value, since they're both below 0, they're both negative, then the cooler temp is negative 12 because it has the greatest absolute value. The bigger the absolute value, if they're both negative, then that's going to be your smaller one, or in this case, your colder one. All right, couple problems left. It says we're going to use this situation and the table for the next couple of questions. It says, in a game played by 5 friends, points can be added to a score or points can be taken away. The table shows the points earned by each player halfway through the game. The game ends when a player earns 50 points. So we don't know all the rules of the game. We just know that there's 5 people playing, and that sometimes when you play the game, your points go up, sometimes they go down. And so here's where they're at right now. Player A is at negative 15, B's at 30, C's at 0, D's at 15, E's at negative 35. So the scores of which 2 players are opposite integers? So what are the opposite integers here? I think it'd be negative 15 and 15, which would be player A and player D. Right? Because negative 15 and 15 are opposite integers from each other. Put that in parentheses. Negative 15 and positive 15. Those are the opposite integers. Okay, next question. Which player needs to earn the least number of points to win the game? Explain how a number line can be used to find the answer. Okay, so to win, the game ends when a player earns 50 points. So which player needs the least number of points to win? Who's closest to winning? In other words, which of these numbers is closest to winning? Which is closest to 50? Well, I'm thinking of if you order them from least to greatest, you could figure out which one is the greatest. They're the closest to winning. So you could order them on a number line. And the furthest to the right, because the further you are to the right, the bigger the numbers, the furthest to the right is closest to winning. So who is that? Who is furthest to the right? Who's closest to 50? Well, I automatically know it's not the negative ones, and because they're below 0, they have a lot more to get before they get close to 50. It's not 0 because 0 is not that close to 50. So is it 30 or 15? Which one's closer to 50? Obviously 30 is. So player B, who has 30 points, is right now closest to winning. They need the least amount of points to win. All right, then the last question is write the scores in order from least to greatest. All right, so we're thinking about a number line which is furthest to the left. Least to greatest is left to right. All right, so which of these would be furthest to the left? Negative 35 would be the very smallest, be furthest to the left, way over there. So we got that one. Then would come the next negative number, which is negative 15. And after negative 15, we would arrive at 0. If we keep moving to the right, we would get to 15. And then finally, we would get to 30. So that would be their scores in order from least to greatest. All right, well, that is it for this lesson. And hopefully you guys felt like you understood absolute value and comparing and ordering positive and negative integers.